Good evening. Hello, everybody, anybody. I want to go ahead and start by letting you know this is the post-lab video, and today I'm going to be going over a few topics. So let's start with the first. We have design and safety. Alright, so for this experiment, especially for safety, I ensured that my flame was set center of the table and nothing was in the way, nothing was in line with this. I didn't have to reach around, I didn't have to reach over the flame. I made sure all my chemicals are set lines, all the way across the table. That way I didn't have to reach over them at all. Ensured that I had the proper clothing on. I made sure that I wore my PPE up until the point of lighting the flame, etc., etc. Just making sure everything fell perfectly, and hope it's alright. I decided to make a few notes right here. I have like 2 pages of notes that help me out with making these videos, and I'll reference these as I go, so if you see me look down, that's why. And alright, on past the safety precautions, I want to go ahead and talk about my disposal. Unfortunately, up until reading, hindsight's 2020, I read everything after I did the experiments, and turns out after you take the sodium copper cloacate solution and you expose it to aluminum, and I'm assuming heat, it makes it harmless. So I did this anyway. I took paper towel and soaked up all this solution and disposed of it that way. And along with that, in my other labs, after I was done with all my materials, also just discarded them in the trash. And upon further investigation, we just had salt, sugar, and vinegar, so everything wouldn't affect the environment. And I made sure of all this before discarding of anything inside the trash. Next, the results. I want to go ahead and talk about the results. So for the results, calculating the percent of copper inside the copper glaucate, the number I found was 30%, and I got that from taking the mass of copper that I scraped off these aluminum washers and dividing it by the total mass of copper glucate. I hope I'm saying that right. Glucate. And yeah, it came out to 30% because I had 1 gram of the copper glucate and then 0.3 grams of just copper after the experiment was done, after I've completed everything, and that's how I got that. For the formula, after following steps on the PDF file after the lab, I started off, of course, being walked through how to find the number of copper inside this formula, and from there I used that to find which one did I find next. I have a scratch piece of paper over here if you would like to see, showing how I found everything. After finding copper, I found carbon, and then I found hydrogen, and then I found the oxygen. And it was really easy. I just put 1 and 2 together on each of those. They had all the formulas laid out. It was actually a very easy system to follow, and I'm thankful for that. So for the second lab, the results, let's go ahead and talk about it. And the conclusion that I got from that was that ionic bonds are stronger than covalent bonds and aren't as easily broken apart. I'm still not 100% sure why, but that's the blanket statement that I could come up with, and I'll have to look further into that and figure out why. But beyond that, I've realized that stearic acid is actually the most weak covalent bond of the 2 covalent bonds, and the 2 covalent bonds in this are sucrose and stearic acid. The sodium chloride is an ionic bond, and that's how I got the assumption that ionic bonds are a lot like harder, less easy to break apart, and absolutely the observed data from this is sucrose or stearic acid is most easily broken apart. On to the critical thinking prompt. A few errors that can be like, inside these projects. On the first lab, talking about with the sodium chloride solution with the glaucate. If the bubbles, if the clear bubbles on bottom aren't completely dissolved away, then I'm assuming that could affect how much buildup of copper was on the aluminum washers, and that could be a pretty good way to knock off your results. Another one for the first experiment would be not allowing the copper to fully dry before weighing it on the weight. This could dramatically knock off the weight of the copper and just mess up your entire results. Now on the second lab, the couple of error points that I could point out would be, if you were to weigh one different, like you were supposed to weigh them all 1 gram apiece. If you were to weigh 1.5 grams, for example, just human error, not taking into account that extra little bit whenever you put the cupcake wrapper. Whenever you weigh the cupcake wrapper, if you didn't zero that scale, then that could knock you off by 5 grams, and that may affect your melting time of your products. The next, I can see it would be human error, and this would be like not starting your clock on time. So I'm actually guilty of that. For I think it was stearic acid, I put it on the heat scale, and I adjusted it, sat there and watched it for a second, and realized I have to start this timer. And I grabbed the timer, started, and by the time I had started it, I look over and the stearic acid has already melted, so I had to redo that test over. I had to weigh out a new sample on a new cupcake pad and redo that part. But I finally got it. I figured it out. For the for the self-reflect, I guess the main troubles that I had would be analyzing experiment data. Just because I looked at all this down bottom and what I can gather from this information, and it seemed so alien to me that it felt impossible to even begin to comprehend. But I read it, I reread it, I had a friend help me with it, and then we read it together and finally started to understand how we could obtain different numbers of atoms for different molecules, and eventually I got it, but that was definitely a wall I had to climb over. Another one would be the disposal, and like I mentioned at the beginning of the video, the disposal was hard for me because, hindsight's 2020. I looked over an important piece of information at the beginning that I could have read from the start, and that cost me it had to be an hour or two just looking through safety data sheets trying to find this copper glaucate that's actually a really, really complex chemical makeup, and it never really gave me a clear answer. And then finally, after the labs, after all the analyzing, after all the data, I run across this one piece of information that tells me exactly what I needed, and I got over that wall too. But those are the two barriers that I had to climb. This is my post video. I hope you liked it, and I hope I answered all the questions. Thank you.